Today we're going to talk about solving equations that include multiplication and division. Hopefully you already watched my other video on adding and subtracting equations, where I talked about how an equation is like a balance scale. So when a balance scale looks like this, it means that the two sides are equal in weight. If one side is higher than the other, it means that one side weighs more than the other. So for an equation, we want them to be equal. So we want our scale to be in balance. So I'm going to go ahead and model this equation right here. So on the left side, you see two x's. So we can call that 2x, or 2 times x. On the other side, we have 6 negatives. So our equation here is 2x equals negative 6. You can think of these x's like twins. They're both exactly the same. So we want to keep everything fair. So we're going to split these negatives equally between the two x's. So each x would get 3 of those negatives. So if 2x equals negative 6, 1x by itself is just negative 3. And if you remember from my last video, that's our goal here. Our goal when we solve an equation is to get the variable by itself. We don't want to know 2 x's, we want to know just 1x. So with adding and subtracting, we used adding to get rid of subtracting and vice versa. Here we're going to do the same thing with multiplication and division. They are what we call inverse operations, so they cancel each other out. Multiplication and division cancel each other out. So for instance, if I took the number 1 and I multiplied it by 5, that gets me 5. And then I divide by 5, that's going to get me back to 1. So the multiplying by 5 and dividing by 5 canceled each other out. We were right back where we started. We're going to go ahead and do 2 examples, 1 multiplication and 1 division. So our multiplication example is going to be 2y equals 12. So remember that when the 2 is right next to the y, that means multiplication. And again, division cancels out multiplication. So if we're trying to get rid of that multiplying by 2, we're going to divide by 2. Because 2 divided by 2 is 1. So that leaves us with just the 1y. Just like when we got the 1x up here. We separated it into 2 equal groups. So 12 divided by 2 is 6, which tells me that y equals 6. But remember, you always want to check your answer in equations because you can easily tell if you got it right. So our original equation was 2 times y equals 12. So we're going to plug in 6 instead of y. So 2 times 6 should equal 12. If it does, which it does in this case, we know that we're correct. Let's just say we had messed up somewhere and we got y equals 5. Well, 2 times 5 does not equal 12, so we would know right then that we messed up. Let's go ahead and look at one that not only has division, but also has a negative number. Because we know how to multiply and divide negative numbers, we're going to see them in our equations. So we want to get c by itself, so we've got to get rid of this divided by 5, which means we're going to use multiplication here. And it has to be negative 5 because this was a negative 5. So you've got to multiply by exactly what you were dividing by. Again, multiplication and division cancel each other out. So that's going to leave us with just the c. And then you can't forget your integer rules. So a positive times a negative is going to give you a negative answer. And so that's going to be negative 50. So we're going to double check. Instead of c divided by negative 5, we're going to put negative 50 divided by negative 5. And it should give us 10. A negative divided by a negative does give us a positive answer. And 5 does go into 50 10 times. So we know we were correct. My next video is going to do 4 more examples. So you're welcome to rewatch this one or watch the other one if you want to see some more examples.